Welcome to this video on the AutoSys Google Cloud Dataproc solution. In this video, you'll discover how to integrate workload automation AutoSys with Google Cloud Dataproc and see the real benefits this brings to the AutoSys community. We'll walk you through the technical details, from identifying the key integration components to understanding the deployment sequence. Then we'll focus on designing and running the submit job to cluster process, and wrap up with a live demo so you can see everything in action. Google Cloud Dataproc is a fully managed Hadoop and Spark service that lets you spin up a production-ready cluster in minutes, run your jobs, and shut it all down just as quickly. Dataproc handles the heavy lifting, provisioning, scaling, and patching, so you can focus on what matters. Crunching data with the open-source tools you already know: Spark, Hadoop, Hive, Pig, Flink, and Presto. It also seamlessly integrates with the rest of Google Cloud, allowing you to read raw files from cloud storage and write polished results directly to BigQuery. Dataproc fits almost any big data use case: batch ETL pipelines, a machine learning model training, real-time streaming, and analytics. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating Google Cloud Dataproc allows us to configure process automation centrally in AutoSys. Subsequently, we can execute and supervise all processes from a single interface. These Google Cloud Dataproc processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute and monitor Google Cloud Dataproc jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your Google Cloud Dataproc execute function job and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Google Cloud Dataproc jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is straightforward, with all job definition properties stored in the AutoSys plain old Java object, POJO job. Target system properties, including endpoint, token, project ID, and other execution parameters, are specified in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the Google Cloud Dataproc server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job and initiates communication with the Google Cloud Dataproc server. In this video, we will use token-based authentication with a proxy. AutoSys supports connections via proxy, providing additional flexibility and security when accessing Google Cloud Dataproc resources. Once authenticated, the agent submits the job to the Google Cloud Dataproc server as a post request. The Dataproc server identifies the matching job and executes it. The job execution returns a JSON response which contains the execution details. Both the Google Cloud Dataproc server and system agent then monitor the job until it reaches its final state. Once the final state is obtained from Dataproc, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses Google Cloud Dataproc Public REST API. To run a Google Cloud Dataproc Pojo job in AutoSys, we first need to establish communication with the Google Cloud Dataproc server. After establishing communication, we can execute and supervise the job. Let's dive into the world of applications and job execution within the Google Cloud Dataproc environment. Let's explore the Google Cloud Dataproc console. In your Google Cloud project, type Dataproc in the search bar and open the service. The left-hand navigation breaks Dataproc into three core areas: clusters, jobs, and workflows. A cluster is simply a fleet of Google Compute Engine virtual machines pre-configured with Spark and Hadoop. In our demo project, we have two clusters: Replica WLA Demo. WLA Dataproc, the one we'll run jobs on, we'll use WLA Dataproc to submit work, then move over to Replica WLA Demo to demonstrate how easy it is to stop and restart a cluster when it's idle. A job is a single task, Spark, Hive, PySpark, you name it, sent to a cluster. From this page, you can view every submitted job, along with its ID, status, and runtime. Submit new jobs or rerun past ones. To kick off quick tutorials, lessons, or launch a predefined workflow. Need to string multiple jobs together? Use a workflow template. A Dataproc workflow enables you to define a sequence of jobs, such as ETL, aggregation, and ML training, and run them end-to-end with a single click. Here you can monitor each step, whether it's an on-demand run, instantiate workflow, or an inline definition, instantiate workflow inline, ensuring your multi-stage pipelines stay consistent, repeatable, and easy to manage. Next, let's proceed to log in to AutoSys. Click the Quick View tab to view the job definition. Select the Submit as Operations to Cluster job to open the job definition. The job employs token-based authentication using a proxy for the demo. When the job is open, click the Quick Edit button to view the required parameters. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name, Google Cloud Dataproc, and the second is the method name, Submit as Operations to Cluster. Now let's look at the gateway parameters. Understanding these gateway parameters is a crucial step in the process. The endpoint parameter indicates where the Google Cloud Dataproc service resides. The token parameter authenticates with Google Cloud Dataproc services using either a file or a concise JSON of the file contents. The project ID parameter identifies your Google Cloud Dataproc project by its name or number, The region parameter indicates the geographical region where Google Cloud Dataproc jobs will be executed. The payload parameter specifies any additional JSON data that should be included with the request. Then we have proxy parameters. The proxy hostname specifies the hostname or IP address of the proxy server to which the connection is established. The proxy port indicates the port number the proxy server uses for communication. The proxy username is required for authentication with the proxy server. The proxy password is the password associated with the username. The max retry parameter is crucial as it determines the maximum number of attempts the job status will be fetched from the Google Cloud Dataproc server for monitoring purposes. The sleep interval parameter specifies the duration of time the system agent should wait before querying the Google Cloud Dataproc API again to obtain the job status. In the event of a brief downtime experienced by the Google Cloud Dataproc service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. Lastly, the log level parameter specifies the level of logging information that should be included in the log file. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job and click Go. To confirm the job's execution, click Yes when prompted. The current run number for the job is 8774. Upon refreshing, a new execution is triggered, increasing the run number from 8774 to 8864. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Make a note of the job ID ending with 2102. We will use this job ID for verification in the Google Cloud Dataproc instance. Now, let's look at the job status in the Google Cloud Dataproc instance. As you can see, this was the job we submitted and it is completed. That wraps up the demo on how AutoSys can integrate with Google Cloud Dataproc to execute and monitor jobs. Thank you for watching this video.